Hey guys, my name is Babu Suresh, working at IBM as a lead architect with over 20 plus years of IT industry experience. I'm based out of Florida in US. This is our second video in our series. Before we begin, I would like to share a brief disclaimer to provide a context for this video. Please take a moment to read it fully before proceeding. Today, we will explore knowledge base with structured data store, mainly with Redshift Serverless. We will also explain how to do with Excel. Here is the topology what we are going to be working today. So the first blue box what we are seeing here is covered under the workshop number 1. If you go to my channel and you will find the workshop number 1, that's what we covered under this blue box. The yellow box what we are looking is what we are going to be covering in today's session. We are going to be creating some Redshift database. We will create some tables. We will create some data into it, and then we will create the knowledge base with structured data store. We will also explain how an Excel can be brought in here into the database, and it can be done for this option. And in the next session, in a different video, which I'll be posting soon, we will cover the last piece of this scenario, which is the Lambda, API gateway, and the browser. So without further delay, let us jump onto the demo in our AWS console. Now we are looking at the Redshift Serverless dashboard. We will be creating one database. As a first step, let us create one workgroup. So now we are looking at the workgroup. We will have some common prefix so that it's easy for us to delete at the end of the session. So this will be our workgroup name. As you scroll down, we will choose the base capacity to a lower number to reduce the cost. This is the maximum capacity it can take. As you scroll down, that is our VPC name. This is our security group name. And we have about 6 subnets here. I'm going to remove 3 subnets to keep it a lower cost. So let us delete 3 subnets here. So as you scroll down, we will take everything default, click next. The namespace, again, we will choose a naming convention. That way it's easy for us to delete at the end of the session to save some cost. This will be our namespace. The database comes with the dev because I'm in the free tier, but you get to choose your database. Our database name is dev, and the credentials, my user is admin. I'm manually entering the password. Make sure to remember this password because you need this to connect later. And the IAM role, we will create one IAM role and we will take this option here. As you scroll down, we will take the default and click next. And this is the summary of our work group. We will create the work group, and it'll take a few minutes to create. So until then, you need to wait or pause and then come back. So while it is creating, let us discuss about what application, what database we are going to create. As we saw in the workshop number 1, we have a fictitious bank called Bank of Mars. So we will continue to use the same concept. I have 3 tables we are going to create. The first table is called customer profile. The second table is called customer account. Third one is the transactions. We will have DDL to create the table. We will have DDL to insert the data for all 3 tables. So that is what we are going to be doing in the next session. Let us go and do that operation. Before we go and create the tables, how about we create the knowledge base? Let us go to the knowledge base screen and let us create the knowledge base. We're going to click create and choose the structured data store. So this will be our prefix for today, and that will be our knowledge base name. Let's remove the underscore and put a hyphen. As you scroll down, there's only one option for query engine called Amazon Redshift. And then we are going to create a new service role here, which is what we are going to be using it. This service role is important. Let us copy because we have to grant some access in the Redshift. I'm going to copy and write it down or store it in this file so that I can use it later when we go to the Redshift editor. Okay, so that will be our Bedrock service role, which we will be using it later. So get back to the screen here. We will click next. And then here the query engine needs to connect to which work group? The work group, whatever we just created in the Redshift, that is what it is. As you scroll down, the Redshift database, what is the database name? We know we have chosen the dev, that is our default database when we created the work group. And the rest of the parameters, we will just choose the default. We are not going to be changing anything here. We will click next. Now we will click the create knowledge base, and this is going to be creating the knowledge base along with the role what you are seeing in the screen. So while it is creating, let us go to the Redshift and then create the tables what we want and load the data what we want. Let us do that. So now let us connect to the database. We have to give the admin user and the password, whatever the password you wrote down earlier, and then click the create connection. Now it will connect to the database. And if you expand, this is our database dev. Public is the schema name for the Redshift. And then there's no table because we just created as an empty database. And we are going to create 3 tables. The first table DDL is here for the customer profile. Let us copy this and paste it inside the editor. Let's run it. Okay, now it created the first table. To insert about 6 customers, we're going to copy this in the editor. Let's click the run. Now it inserted 6 customers under the profile table. Let us go to the accounts table. Let's copy the create table DDL and then paste this here and then click run. Now the second table, account table, is created. Let's copy the insert statement, copy in the editor, click run. This will create the accounts what we need for those customers. Now let's go and create the last and final table, transactions. Copy this guy, paste it here, click run. It is creating the table. Now let us copy the transactions. I believe there are 13 transactions here. Copy this insert statement here, click run. So now we have created the transactions. Let us see whatever we have done so far is all right. Let us do some cross verification by running few queries. I'm copying some predefined queries here as a comment. Let's paste it, and then we will copy the first command and run that command outside the comment to see how many records in the customer profile. So we have 6 customers. Similarly, let us check how many accounts are there to double check what we did is right. So there are about 6 accounts here. Similarly, let us see whether the transaction table and the data is looking good. We are running the query to select all the records in the transaction table. So we have about 13 transactions. So that is looking good. At this point, we have created 3 tables and the required data for all those 3 tables. So let us go back to the knowledge base creation screen which we created earlier. So as soon as you open, let us go and click the knowledge base. We are going to click it. As soon as you open, you will see the status which will say available. And then we are going to take the service role. If you look at the status, it says available now. Let us take the service role and we are going to store it. We already stored it here. This is a service role which we copied earlier. Let us do some operations with this service role. So now we are in the Redshift query editor. We are going to run one query in one of the system table. This table will tell how many users are. There are 2 users in this table. We are going to copy this service role, and then we are going to construct our SQL to grant access, that is to grant read access for the tables what we need, and this command is to create the user inside. So let us copy all these commands and paste it in the query editor. So I'm pasting it, and then we'll copy only the commands what we need outside, which is the create user. So let us run this guy. So that went through successfully. Now let us make sure this user is created inside the table. So we're going to look inside the table. There should be 3 users at this point. So the second row is what we just created. That looks good. Now let us grant the read access for this user, which is nothing but the Bedrock service role, so that Bedrock can read this database schema tables, whatever we are granting access. So that command went through. So at this point, we have done whatever is required inside the Redshift database. So now if you open the knowledge base we just created, the status will show available. It will turn progress to available, and then yes, it is available. And also we have test knowledge which is disabled now. That will become enabled after you click the sync. So let us click the sync, and sync is running now. Since our data is very small, it should complete soon. As soon as it's complete, we should be able to ready to test. So the sync is complete with the green color. Let us see. The test knowledge base is ready to go. We clicked it, and then this is the screen you would see, and click the select model. We are going to select the Amazon Now Pro on demand and click apply. At this point, we can give the question to test the engine. So we're going to copy some of the questions which we already have here. So let us do that. We are copying the first question. Before we copy, let us make sure the answer what we are looking is indeed correct. So we are going to look at the database and find out who is a teenager. So if you look at the date of birth, 4th column, the first row, date of birth is 2009, which is 18 years or younger. So that is the only person date of birth is 18 years or younger. Everybody else is older. So it should return only one person according to the database what we saw. Let us go and run this question against this engine and see what the answer it is going to give us. So the engine is thinking at this time, and it came back with the answer saying that the customer name is 001, name is Nova Blaster Beam. In fact, that is the right answer what we see inside this query editor. So that is good. So it answered the first question correct. Now if you want to know how this query is constructed, click the details and it will tell you the SQL it created in order to get you the answer. This is very helpful in case if you want to debug or take a look at more deeper on this answer. So that is a pretty good way of taking a look at how engine really worked underneath. Let us go to the second question. The second question is a little complicated. Why? The first question's answer lied in just one table, and in the second question the answer is lying across 2 tables. So the engine needs to do some work to know how to join, in which fields to join, and how to form the structured query language. So let us ask the question number 2, which is to show me all inactive accounts and its owner details. The engine is thinking now. Let us see what it answers. So the answer came back. It says Glorp Squidward. So that is the customer. It says inactive customer. Let us go back to the database directly and see which account is inactive. So let us run a query against account table, pull all the records in the account table, and if you look at the last column, status, the fourth record says inactive, which is account 04, customer 03. So what is the customer 03 name? In order to find out, go to the customer profile and select all the records and find out the customer 3, whose name is Glorp Squidward. So in fact, that is what the answer this engine gave us, which is pretty correct. So the first two questions, the answer came back correct. If you want to take a look at deep into the SQL, how it created and what is the SQL syntax, you can take a look at it and how it joined, how it formed the structured query language. So that is pretty good. So now let us go on, take a look at third question. Third question even more complicated. Why? The answer is lying across 3 tables. So let us run this question. In fact, instead of last 2 weeks, let's say last 1 week. Show me all the transactions that occurred within last 1 week and its customer names, which means the answer is across 3 tables. Let us see what it comes up with. So it came back with the answer saying that query did not return any transaction. In fact, that is right. Let us go and cross-verify what it answered is right. So we're going to pull all the transactions from the transaction table and see anything happened within last 1 week. If you see anything in August, there is no transaction. So that means the answer what it gave is correct. So let us also see whether anything happened in last 2 weeks. There's only one transaction, which is the transaction number 12 that happened within last 2 weeks, which is July 29th. Let us go and put this question. So let us ask, show me all the transactions that occurred within last 2 weeks. If it's today is August 9th, then July 29th is one record that should come up as the answer. The engine is thinking. Let us see what it says. So it says the transaction number 12, that is the right answer, whose name is Zargon Stardust. So if you look at it, this has combined 3 tables. Okay, the transaction number 12 is here. So let us see one by one here. Okay, so transaction, we know we're going to look at the account to see who is the customer. If you look at it, the customer is mapped here, and take the customer and then go and run that customer number against the customer profile, and it will say this is a customer whose name is Zargon Stardust. So that is pretty good answer what it gave. In fact, it is indeed correct. It is smartly joined 3 tables and created the structure language and gave us the answer. So that completes of our demo of what we wanted to achieve in this workshop. However, so now you are looking at the query editor. I wanted to show how you can bring the Excel into the picture to test your knowledge base with structured data store. I'm not going to do the demo, but I'll explain because it is very straightforward and simple, and it's a proven technology. There's nothing new here. Before you bring it here, make sure to upload your Excel sheet in the S3. That is one option. Or you can also keep it in your laptop and you can directly bring it from your laptop. So there are 2 options here I'm going to show here. I believe the Excel sheet should be in a CSV format. So here you see the load data button inside the query editor. Click that and you have 2 options. One from load from local, one from load from S3. If you click the load from S3, and you can choose the bucket of your choice and click the region and make sure the file format is in the desired option what we have, and then click next. Once you click next, then you will have an option to tell whether you want to create the table from scratch based on the Excel headers and then load the data. That is option 1. Or you wanted to retain a table which you may have already created inside the Redshift, and you just wanted to only copy the data from your Excel. So you will have that options shown in the screen. So that way you can bring the Excel sheet into your structured database, and then you can continue with your operation. So that is how you're going to pull the Excel into the Redshift and complete your knowledge-based structured data store exercise. So far what we have seen is how to bring the Excel file into the Redshift SQL database. Now there's one other important thing which I want to tell you. The knowledge base with vector store, what you see in the blue box, this functionality will have an option to take Excel file as an input. So initially when I started this exercise, I was bringing the Excel into the blue box and trying to get an answer of my use case, and it didn't answer. The reason being, if you bring the Excel in this blue box path, which is the knowledge base with vector store, the Excel will be treated as unstructured data. If you bring the Excel in this yellow box, it will be treated as a structured data. So you may want to decide how you want to treat the Excel sheet according to your use case. I understand very likely most of us are all using Excel for structured rather than unstructured, but it is a very important thing. I got fumbled and tumbled initially when I started first on this, and it took some time to figure out to do the Excel in the other side before you can see the results of your choice. So that is important things, guys. Let us summarize what we did today. What we did today is, in this yellow box, we created the Redshift database, we created the table manually, we created the data manually using the query editors, and then we created the component called knowledge base with structured data store using the Bedrock, and we ran the Bedrock using the LLM of our choice, Nova Pro, and it was answering our questions based on what we saw. That worked very good, pretty good. Also, I explained how you can bring the Excel into the Redshift to make use of the functionality of this yellow box. Also, we saw when you want to bring the Excel into the blue box if you want to treat as an unstructured database. That covers what we talked about in workshop number 1, blue box, workshop number 2, yellow box, which is this workshop. The next workshop, what we are going to be doing is putting an end-to-end application by creating some Lambda, by creating some API gateway, and we will have some UI code, and we will go outside the AWS and run it through a browser like any typical chat GPT kind of users. So that is what our next exercise is going to be. Until then, thank you all for watching. We will see you in the next video.